experiment is related to the aggregation of colloidal particles to form a gel, an arrested structure, and the gel is ubiquitous in nature. What we have in mind is to study the aging, the evolution of this gel. And this is a very important point because every material ages and fails, so it's important to study the evolution of this material in times. Our colloidal system is made by very small spherical particle in which the aggregation is promoted by increasing the temperature, because essentially the particles are covered by polymer chain, and when you increase the temperature we reduce the solubility of the polymer with the solvent, and this promotes the aggregation of the particle. One of the advantages of this method is if you reduce again the temperature, the system completely remelts, and so you can repeat the experiment. And another advantage of using this system is that if you change the temperature, you can tune precisely the interaction between the particles. Of course, it's the same problem that you have with earthquake. Essentially, you store the stress in the crust, and when the crust evolves at a certain point, you have a catastrophic failure. And my gel can be a model to study how the stress propagates in this material. And our preliminary result, for instance, showed that changing the concentration of the interaction between the particles, we can have different way in which the stress propagates. If you are able to find some precursor of the failure, you can say, okay, now it's time to change the part, to change the object, to change the material, and substitute it with a fresh one. And I think it's really important, especially when you are on Mars or away, that maybe you have to construct soft material using the sand of the Mars. You can find a method to monitor the failure of your material and to anticipate the complete failure of your system. So I think this can be useful for exploration. One of the key motivations to work with NASA is that they develop this confocal microscope, and our mission is called ACE-T, where T stands for temperature, because one of the key points of our research is to be able to control the temperature, very precisely the temperature of the system, because the temperature controls the interaction between the particles. And the ACE-T project, NASA developed an advanced stage for the microscope that is able to control precisely the temperature of the system. We cannot make this study on Earth, or better, we can make, but the result is of course completely different because gravitational stress perturbs this material. So it's mandatory to have make this research on space to see the evolution of this material. I have a collaboration with the European Space Agency. In that case, I'm developing a light scattering setup. So essentially, the combination of a light scattering setup and the confocal microscope give me everything that I need to try to understand the problem of gelations. One of the nice things of the confocal microscope is the ability to give the 3D structure of your material. So what I plan to do is to use the structure of my gel that we obtained this morning to print with a 3D printer an enlarged copy of the gel and use that as a gadget for the science team. But what is also interesting is that in the future, when we have the result from the space research, I will also have the structure of the gel in space that will be completely different, and also we will print this 3D copy, and I think that I can use on my desk, but also useful for students, because when you want to explain to the student why it's important to make research in microgravity condition, I think that if you put something that can visualize and touch, it can be very useful for teaching. The investigation of gel solidification in space was made in collaboration with Professor Roberto Piazza from Politecnico Milano, Luca Cipelletti from the University of Montpellier, with the ACE team of NASA, and also we have a collaboration with the European Space Agency In fact, me and Roberto Piazza and Luca Cipoletti are the designer of the Colis setup that is made by European Space Agency. I'm very happy to be here, the NASA Glenn Research Center, to work with the scientists and engineers that help me to transform my idea in reality. The thing that I really appreciate is how they help me in make real what I had in my mind. So I have to thank to all these people.